Hello, awesome APE students. Hanging out with Pippa. Who would like to get down now? There you go, Pips. Okay. Hanging out at home, getting ready to give a lecture on 2.5 natural disruptions to ecosystems. See if she might scratch at the door. She doesn't want to be in here. Go play with somebody else. You know how it is. All right. So today's lecture is going to be on page 8. It's not very long, but there's a lot of work we're going to do in between. So when we get into class, we'll continue. Our objective is to explain how natural disruptions, both short and long term, impact ecosystems. We'll talk about the natural ones and then how it's different when humans make disruptions to ecosystems. So ecosystems have evolved to change under extreme circumstances. So for example, like the tide, right? Tide pools, like they've water or no water, like it's really different. And that happens over and over again all the time. They've evolved to work within very serious disruptions, volcanoes, all that kind of stuff, right? Okay, so I'm kind of giving away some of the things for the next slide. So what are some natural disturbances? Sorry, you can't. Well, that's okay. What are some natural disturbances that could impact ecosystems? It says on your handout right now. So could you, maybe the picture gives you an idea? You could pause and write down some ideas, and then I'm going to tell you some. All right, so volcanoes, storms, huge storms like you can see here from space, that's a big tornado. Earthquakes, floods, mudslides, heat waves, drought, fire, disease, freezing. These are all natural things that the world has to know how to, not know, but has to be able to react to. So we have two kinds of strength that an ecosystem can have: resistance and resilience. So resistance is the ability to remain unchanged when there's something that disturbs it. And resilience is the ability of an ecosystem to recover and return to its pre-disturbed state. So in this case, and I think I need to exit to show you the kettlebell. Do you see the kettlebell there? There's a kettlebell, and it's the kettlebell compared to the Weeble Wobble, okay? So for the resistance, you want to think about it like being able to push over something heavy. So it's not going to change. So resistance is going to be that, all kinds of things happen and the ecosystem keeps going, like pushing over a kettlebell. Whereas resilience is going to be to recover from it. So you push it over, it falls, and then it comes back. So I don't know if you know about Weeble Wobbles, but they're kind of cool. Like they were a little toy that you could play with in like the 60s and 70s, and they would wobble and come right back up. Okay, so either of those is going to work for an ecosystem. And in fact, when we start talking about succession, sometimes that's exactly what has to happen. So you should sketch this graph on your paper. You could just sketch it over to the side. Resistance is going to be in blue, or the straight line if you don't have colors. And then resilience is in red, right? So if you have a disturbance, the resistant ecosystem just won't change. It'll keep going. Whereas the resilient ecosystem will change really a whole lot and then come back over time. All right. Whereas if you have a problem with a resistant ecosystem, it could just go down and stay and never come back up. Okay. So pause and draw the ecosystem function versus time with the resistance and resilient. Draw that into your packet. And then we're going to talk about this graph, the intermediate disturbance hypothesis. All right. So the intermediate disturbance hypothesis is where an ecosystem requires a certain level of disturbance for maximum, for the ability to work the best way. So so a certain level of disturbance for maximum healthy for maximum health and biodiversity. Okay, so you can sketch out this graph on your intermediate disturbance hypothesis, okay, in that box on page 8. So what's going to happen here is you have low diversity and high diversity, and then infrequent to frequent disturbances, something like a storm or drought, to a small extent to a large extent. So anytime you have a huge disturbance, things are going to have a hard time coming back. And if it's a little disturbance, it's not going to be as bad. And then the time since impact. So if you wait longer, you'll get a chance to see the ecosystems recovering. All right, so basically, if you have infrequent, small, long time since impact, you're going to get the lowest diversity. And then the minimum 2 is if you have frequent, large, and a short time since impact, you're going to have another minimum level of diversity. But somewhere in between here, with just the right amount of disturbance and frequency and interactions between species, you're going to get the most diversity in an ecosystem. So the point is that you don't want to just leave everything and, oh, take care of it and never let it do anything. The world is a crazy, disruptive place, and things have evolved to be that way. All right. So like I said, the intertidal zone is a really great example of how disturbances can keep diversity. So if there wasn't tides coming in and out constantly, one species would thrive over another. But because of this, they turn over, and there's an incredible amount of diversity. Hopefully you've gotten to go tide pooling before in your life. It's a really wonderful way to see a lot of different sorts of things. And that's because of the extreme disturbances. So we will in class be doing the biointeractive for paleoclimate, and then looking at historical sea level change and habitat changes. Okay. And then the last slide for this lecture, and then we'll talk about wildlife migration. We're going to do all those activities in class. But the last slide is what makes modern day changes with anthropogenic causes different from all the previous natural changes? How can the world handle coming back from a volcano, but it's having a hard time coming back from what humans do? And the answer is 2 things: frequency and intensity. Human disruptions are often much more frequent than they happen in nature, and they're much more intense. All right, so we'll keep talking about what humans are doing to nature and how we can work in harmony with nature, because we really do depend on it for everything that we do. Thanks for listening.